Hi kids. What I'm going to do is I'm going to do this video a little bit different this time. And basically, I'm going to work from the book, and I would like you to take out your book and open up to topic 9.1 and look at pages, which will be on pages 232 to 233. Okay? And as I'm going along with the information in the book up here, pointing out to it and stuff like that, I would like you to follow along also in your book so that you understand what it is they're talking about in the book. Pretty much the same thing that we would do in class, except for this time I'm not going to try and hold the book up to the camera and read from the book and that sort of thing. I'll have you follow along in the book yourself. Okay? So anyways, pause the video and open up to pages 232 and 233. And I will situate the camera here to help you out here. All right? Okay, here we go. Alrighty, now, one of the things that I'd like to point out to you is that on page 233, 232, they are talking about understanding ratios. And if you read along as I read along, we'll have an idea of what they're talking about. What is a mathematical way to compare quantities? Tom's Pet Service takes care of cats and dogs. Currently, there are more dogs than cats. Compare the number of cats to the number of dogs. Then compare the number of cats to the total number of pets at Tom's Pet Service. Well, when you're looking at your book, one of the things that you'll find is that they conveniently tell you that there are a total of 17 dogs, okay, and there are 14 cats. Okay? And then they give you a nice picture of all those critters. Alright? So anyways, what they're talking about are ratios. Okay? And so when we talk about a ratio, we are talking about comparing numbers. Okay? And in the first part of the book, they tell you the definition of a ratio. A ratio is a relationship where for every X units of one quantity, there are Y units of another quantity. In other words, you could say dogs are the X's and cats are the Y's. Or what you could do is you could say all the pets together are the X value and the cats alone would represent the Y value. Okay? So there's different ways that you can compare the same number of animals. Okay, or same types of things. All right. So, anyways, let me kind of like go through the information in the book now. All right. One of the things that they talk about is writing ratios 3 different ways. Okay, and I'm going to put up a couple shapes here. And so now we have a group of shapes up here, okay? And one of the things you notice that we have 1, 2, 3, 4 circles. We have 1, 2, 3 squares, 1, 2, 3 triangles, all right? Now we can begin making a ratio, many different ratios, when we look at this information, okay? So for example, the first way you can write a ratio is with using the word 2. Okay? And what's important is if I say I want to compare circles to squares, I could certainly do that. Okay? I could compare the circles to the squares. Now, the important thing here is to know that circles is being mentioned first. Squares are being second. So your ratio will show that, okay? So the first thing we want to do is count the number of circles. 1, 2, 3, 4. We have 4 circles. To the number of squares, we have 3 squares. So that is your basic ratio of circles to squares. Circles is the first number because it's mentioned first in the ratio comparison, and squares are second. Now you've got to be careful here because sometimes kids will automatically think the smaller number needs to go first. And it doesn't. It has to do with how you are identifying the comparison. Okay? So, that's one way you could write a ratio. Well, now let's keep thinking about circles to squares. Okay? Circles to squares. Okay? Let's keep thinking about that. And the other way you can do it is to use colons. Okay? And simply write 4 to 3. A 4 to 3 ratio. And the third way you can write it is as a fraction. 4 to 3. And a ratio, it acts and operates just like a fraction, but what's different is you're thinking of two quantities here versus one quantity, okay? But yes, it is a fraction by all numerical purposes because you're talking about a relationship through division, okay? So anyways, those are the three ways that you can write a ratio, using the word to, using colons, or using a fraction bar. All right, so let's write a couple more ratios. All right, and look at the different types of ratios that you can have. Okay, one of the types that you can have is a parts to parts ratio. Okay, a part to part ratio. And that means you're going to compare one part to another part. So in this case, we could say, okay, now let's compare triangles. Okay, triangles to circles. Okay, triangles to circles. So if we do that, we'll take our triangle number. We have 1, 2, 3. So we're going to say 3, 2, 4. Okay? And so you can see that we have 3 of the triangles and 4 circles. This is a parts to part. These are both parts in the group. All right? And then we could do another example of that. And what we could do is we could do squares to circles. Okay, so if we did squares to circles, we would then have 1, 2, 3, another 3 to 4 ratio. Okay, so that's the comparison of parts to parts. All right, now another way that you can compare is to compare parts to the whole. In other words, parts to the whole would be comparing a part to all of the numbers. And in that case, we'd have to know that we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 items. Okay? So if we have 10 items and we wanted to compare, let's say, circles to all shapes, we'd find that we have a totally new type of ratio situation. Okay, we have our circles. There are 4 circles to the total of all shapes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, it would be a 4 to 10 ratio. Okay, this is a parts to the whole. All right, and again, you can really kind of break it down any way you want. You could break it down into polygons compared to polygons, round versus square. Anything you want, you could compare. All right, if you have numerical values. So those are the two important types of ratios that they teach in the book. All right, now there's a couple things that I want to point out to you. Okay, like for example, if we decided to compare triangles, whoops, make sure I spell that right for us. If I wanted to compare triangles to, let's go with squares. if I wanted to compare triangles to squares, what I could do is I could say, okay, I have 3 triangles and I have 3 squares. Now this ratio, you'll notice, is a 1-to-1 ratio. That means that for every 1 triangle you have, it matches up to 1 square. So that would give you what is known as a 1-to-1 ratio. Okay? They match up completely, 1-to-1. All right? And so that's kind of a neat concept to understand, especially when you're looking at ratios. Okay? So let's take a look at something else that will probably come up when you're working with ratios. And let's throw a few more shapes, let's throw in a few more squares, okay? So let's add 1, 2, 3 more squares here, okay? So now, if we look at our ratio of triangles to squares, we're going to write it differently. Okay, we're going to write it. We have 3 triangles, okay? And we have 1, 2, 3, 4, 5, 6 squares. Now, when you look at these numbers like this, you think, okay, these are both divisible by the greatest common factor of 3. And if you write it in a fraction form, you really begin to realize that you could simplify this or reduce it into lower terms. Because these, okay, 3 and 6 are what we call the terms of the ratio. These are the terms of the ratio. Okay, so now you kind of know what we mean when we say lowest terms. And so you could divide those by a greatest common factor, which would be 3, and you will get 1 and 2, which you know is read as a half or a 1-to-2 ratio. In other words, what we know is that for every 1 triangle, there are 2 squares. For every 1 triangle, there are 2 squares. For every 1 triangle, there are 2 squares. All right? And so that would be a 3-to-6 ratio or a 1-to-2 ratio. All right? Either way is acceptable, but you might want to be aware of that as you are working with ratios. Okay? So anyways, that is pretty much what the book covers in terms of ratios and related information. So let's take a look at what we have here in the book and actually try a practice problem or two. Okay? Let's try a practice problem. Let's go with this practice problem right here. And it says, a 6th grade basketball team has 3 centers, 5 forwards, and 6 guards. Write a ratio for each comparison in 3 different ways. Why don't you do this problem right there? Okay? Why don't you go ahead and pause the video, and I'll set up and get ready while you work out the problem. All right, let's see how you did. Okay, hopefully you paused the video and you did the work. Okay, so what it asks us is it says they want to compare forwards to guards. Okay, so we're going to write that down. Forwards to the guards. All right. Okay, forwards to guards, and they want us to write a ratio. Well, the first thing that we want to know is that there are 3 centers. So what we're going to do is we're going to write that down. Let's just get that information out there. There are 3 centers, and there are 5 forwards, and there are 6 guards. Okay, so we have our forward, centers, guard, and they want a ratio for forwards to guards. Well, we have 5 forwards and we have 6 guards. So that ratio would be 5 to 6. If we write it 3 different ways, we could write it as 5 to 6, and we could write it as 5 over 6. Okay? And so that would be the answer for number 1, forwards to guards. Okay? Let's take a look at number 2 that they ask us. Okay. Number 2, they want to know centers to totals. Okay, so their number 2, they want to know centers to total. All right, so let's write that down. Centers to the total. All right, well, in this case, we have to come up with the centers. There's 3 centers, and the total would be 3 plus 5 is 8, plus 6 is 14. So it's a 3 to 14 ratio for number 2, centers to total. And again, if we wrote it in 3 different ways, we could do 3 to 14, and we could write it as a fractional comparison, 3 to 14. Okay? So, now let's check our answer for number 3. Number 3, they're asking us centers to guards. Centers to guards. Okay? So let's compare the centers to the guards. There are 3 centers, and there are 6 guards. Now, some of you may have wrote this in lowest terms. You may have decided to write it as a 1 to 2 ratio, and I would find that acceptable if you've made that jump already. Okay, and then if we were using words, it would be 3 to 6 or 1 to 2. And again, down here, 3 to 6 or 1 to 2. Okay? And so there you have some working knowledge for ratios. All right? Okay, at this point, what I've done is I've kind of gone over the basics as they are presented in the books, using different examples. In the book, they use examples with dogs and pets, but the information is the same. I've just explained it a little bit different to you. If you have further questions, you can watch the Pearson video, and I've also included a link to another math video on YouTube. I believe Math is Fun or one of those guys. Anyways, they're good. It's a good video. So if you still needed more information on ratios, feel free to go over the book again in Pearson Realize video and connect to the link that I provided down below. All right? Have a good day, and if you have any questions, see me.